Most people think coffee machine repair is difficult because espresso machines are complicated. They assume technicians have secret knowledge, expensive tools, or years of impossible experience that normal people could never understand. So when something goes wrong, weak pressure, inconsistent extraction, leaking water, strange sounds, poor steam, bitter espresso, sour shots, grinder inconsistency, or unstable machine behavior, the average person immediately panics. They start searching random YouTube videos, replacing parts blindly, changing multiple variables at once, or assuming the machine is completely broken without actually understanding what the real problem is. And this is exactly where most people fail. Not because they lack intelligence, and not because the machine is impossible to fix, but because they never learned how to diagnose problems properly in the first place. They learned reactions instead of systems, guessing instead of diagnosis, random fixes instead of structured troubleshooting. And over time, that creates frustration, wasted money, unnecessary repairs, inconsistent espresso, and complete confusion every time the machine behaves differently. But the reality is that most espresso machine problems are not random at all. Machines follow patterns. Pressure follows patterns. Flow follows patterns. Extraction follows patterns. Grinder behavior follows patterns. Even failures follow patterns. And once you understand how to recognize those patterns, espresso machines stop feeling mysterious and start becoming logical systems you can actually understand, troubleshoot, and control. Welcome to this complete coffee machine diagnostics and repair training system, where the goal is not just teaching you how to replace parts or follow random repair tutorials, but helping you develop the mindset and diagnostic logic real technicians use to identify problems accurately before touching the machine. Because the biggest difference between beginners and professionals is not tools, expensive equipment, or even experience alone. It's the ability to observe symptoms calmly, isolate variables logically, and understand what the machine is actually communicating through pressure, flow, sound, extraction behavior, heat, resistance, and performance changes. In this training, we're going to break down espresso machines and grinders in a practical, real-world way designed specifically for beginners, baristas, coffee enthusiasts, cafe owners, and aspiring technicians who want to stop feeling overwhelmed every time something goes wrong. You're going to learn how technicians think, why machines fail, how grinders influence extraction, how pressure and flow interact, how to identify common faults, and how to troubleshoot systems methodically instead of emotionally. This is not about memorizing random fixes. This is about building a structured understanding that allows you to diagnose problems confidently across different machines, different symptoms, and different repair situations. One of the biggest mistakes beginners make is assuming every coffee problem has a simple universal answer. Sour espresso? Grind finer. Bitter espresso? Grind coarser. Low pressure? Replace the pump. Weak extraction? Buy a better grinder. But real technicians know that symptoms cannot be separated from context. Sourness may come from under-extraction, but it may also come from unstable temperature, poor puck preparation, uneven flow, incorrect dosing, or grinder inconsistency. Weak pressure may come from pump issues, but it could also come from scale buildup, leaking seals, restricted flow, poor grind resistance, or block components. This is why random internet advice often creates more confusion than clarity. Because without understanding the full system behind the symptom, people start treating symptoms blindly instead of identifying root causes accurately. And that cycle leads to unnecessary part replacements, wasted money, damaged machines, and endless frustration. This is why diagnosis matters more than random repair knowledge. Because good diagnosis reduces unnecessary repairs before they even happen. By the end of this training, the goal is for you to stop seeing espresso machines as unpredictable boxes full of random problems and start seeing them as understandable systems built around pressure, heat, resistance, flow, extraction, and mechanical behavior. Instead of panicking when the machine changes, you'll begin observing patterns. Instead of replacing random parts, you'll start isolating causes logically. Instead of copying random fixes online, you'll build the confidence to understand what is actually happening inside the machine yourself. And that transformation changes everything because it shifts you from reactive guessing into structured diagnosis. That is the mindset real technicians develop over years of experience. And once you start building it, troubleshooting becomes calmer, faster, more accurate, and dramatically less intimidating. One of the biggest misconceptions in the coffee world is the idea that repairing espresso machines is mainly about technical skill. People assume the hardest part is opening the machine, replacing components, understanding wiring, or learning mechanical procedures. But in reality, most failed repairs happen long before a screwdriver ever touches the machine. They fail during diagnosis. Because if the diagnosis is wrong, everything after that becomes guesswork built on a false assumption. This is why so many people replace pumps that were never bad, buy grinders they never needed, change parts blindly, or spend weeks chasing problems that were caused by something simple hiding elsewhere in the system. And the frustrating part is that every wrong repair creates even more confusion because once multiple variables start changing at the same time, people lose the ability to understand what actually fixed the issue or what made it worse. That's why professional technicians approach machines differently. They don't begin with repairs. They begin with observation. They study symptoms carefully. They isolate variables. They look for patterns. They ask what changed, what remained stable, and what the machine is communicating through pressure behavior, flow instability, sound changes, extraction inconsistencies, temperature fluctuations, and mechanical responses. To beginners, machines feel random. To technicians, machines give clues constantly. Guesswork is expensive, and not only financially. Every unnecessary part replacement wastes time, creates frustration, and slowly destroys confidence. Many beginners enter coffee machine repair believing that experience means memorizing fixes, but experienced technicians know something far more important. No symptom exists alone. Low pressure is connected to flow behavior. Flow behavior is connected to grind resistance. Grind resistance is connected to burr condition, calibration, puck preparation, and extraction variables. Heating problems influence taste. Scale buildup affects pressure stability. Dirty systems create symptoms that imitate mechanical failures. Everything inside the machine interacts together as one system. And when people fail to understand those relationships, they start attacking symptoms randomly instead of understanding the structure underneath the problem itself. This is why two people can look at the same machine and reach completely different conclusions. One sees chaos. The other sees a sequence of connected behaviors that narrow the problem logically. That difference is not magic. It's diagnostic thinking. A huge reason beginners stay trapped in confusion is because most repair content online focuses on isolated fixes instead of understanding. People search for specific symptoms like espresso machine no pressure or coffee grinder inconsistent grind, then follow random tutorials without understanding why the problem happened in the first place. And sometimes those fixes appear to work temporarily, which creates the illusion of understanding even though the underlying diagnosis was never truly clear. But real technicians do not rely on isolated tricks. They rely on structured workflows. Because a symptom that looks identical externally can have completely different causes internally. Weak extraction may come from grinder inconsistency, restricted flow, pump instability, scale buildup, poor puck resistance, or temperature fluctuation. Similar symptoms do not always mean identical failures. That's why blindly copying repairs from random videos often creates more confusion than progress. Without diagnostic structure, people become dependent on endless tutorials forever instead of developing the ability to understand machines independently. Real technicians are not calm because machines never fail. They are calm because they trust the process of diagnosis. They know that pressure, temperature, extraction behavior, sound, steam performance, grinder consistency, and flow characteristics all provide information if observed correctly. They understand that machines rarely fail completely without warning. Most failures begin as small symptoms that gradually develop over time. Slightly unstable pressure, slower heating, inconsistent extraction, weaker steam, minor leaks, unusual sounds, reduced flow stability. And because experienced technicians learn to recognize those early patterns, they often identify problems long before catastrophic failure happens. This is one of the biggest mindset shifts you need to develop if you want to think like a professional technician. Stop reacting emotionally to symptoms. Start observing behavior systematically. Real technicians are not calm because machines never fail. They are calm because they trust the process of diagnosis. They know that pressure, temperature, extraction behavior, sound, steam performance, grinder consistency, and flow characteristics all provide information if observed correctly. They understand that machines rarely fail completely without warning. Most failures begin as small symptoms that gradually develop over time. Slightly unstable pressure, slower heating, inconsistent extraction, weaker steam, minor leaks, unusual sounds, reduced flow stability. And because experienced technicians learn to recognize those early patterns, they often identify problems long before catastrophic failure happens. This is one of the biggest mindset shifts you need to develop if you want to think like a professional technician. Stop reacting emotionally to symptoms. The purpose of this training is not simply teaching you how to repair one machine or solve one isolated problem. The real goal is helping you build a framework for understanding machines logically across different situations, different symptoms, and different repair environments. Because once you understand how systems interact, pressure, flow, extraction, resistance, temperature, grinders, maintenance, and machine behavior, you stop depending on memorized fixes entirely. You begin diagnosing through understanding instead of imitation. And that changes everything, because confidence no longer comes from hoping a repair works. Confidence comes from understanding why it should work before you even begin. That is the difference between random repair attempts and true technician thinking. Most people believe coffee machines fail suddenly. One day the espresso tastes fine. The next day pressure disappears, extraction becomes unstable, steam weakens, leaks appear, or the grinder starts behaving inconsistently, and it feels like the machine simply broke overnight for no reason. But experienced technicians know that machines almost never fail randomly. Most problems begin slowly and quietly long before the major symptoms appear. Tiny changes in pressure stability, inconsistent flow behavior, gradual scale buildup, worn seals, overheating components, burr wear, restricted pathways, poor maintenance habits, and repeated operator mistakes slowly push the machine toward instability over time. The problem is that beginners usually don't recognize these early warning signs because they don't yet understand how the system behaves under normal conditions. And because they miss the early clues, they only notice the problem once performance becomes impossible to ignore. This is why understanding how machines fail is one of the most important foundations in coffee machine diagnostics. Because once you understand the patterns behind failure, machines stop feeling unpredictable and start becoming understandable systems with logical behavior. One of the biggest mistakes beginners make is viewing espresso machine problems as isolated issues instead of system behavior. They see weak espresso and immediately blame the grinder. They see low pressure and immediately blame the pump. They taste bitterness and immediately change grind size. But espresso machines are systems where pressure, temperature, water flow, resistance, extraction, grinder consistency, maintenance, and mechanical condition all influence each other continuously. A problem in one area often creates symptoms somewhere else entirely. Scale buildup inside the boiler can affect heating stability. Heating instability changes extraction behavior. Extraction changes flavor balance. Grinder inconsistency changes puck resistance. Poor resistance affects pressure behavior. Pressure instability changes flow characteristics. Everything connects together. And until you understand those relationships, troubleshooting becomes random because you're reacting to isolated symptoms without understanding the larger system underneath them. A huge percentage of espresso machine problems come from neglect rather than catastrophic mechanical failure. Machines constantly operate under heat, pressure, minerals, moisture, coffee oils, and physical wear. Every extraction leaves residue. Every heating cycle deposits minerals. Every steaming session creates buildup inside the milk system. And without regular maintenance, those layers slowly accumulate until machine performance becomes unstable. Water pathways narrow. Pressure becomes inconsistent. Flow slows down. Temperature stability weakens. Steam power decreases. Old seals begin leaking. Coffee residue affects extraction flavor. But because these changes happen gradually, many people adapt to the decline without realizing how much performance has deteriorated. Then eventually the machine reaches a tipping point where symptoms become impossible to ignore, and suddenly it feels like the machine failed, even though the problem was developing slowly for months. Not all machine problems come from the machine itself. Many failures are unintentionally created by the operator. Using poor water quality accelerates scale buildup. Ignoring cleaning routines allows residue accumulation. Constantly changing grind settings aggressively creates extraction instability. Using dull grinder burrs weakens consistency. Running machines without proper warm-up affects temperature stability. Over-tightening components damages seals. Forcing adjustments carelessly creates alignment problems. And because beginners often lack a structured workflow, they accidentally introduce multiple variables at the same time, making diagnosis even more confusing afterward. This is why technicians focus heavily on habits and workflow consistency. Because stable machine behavior depends not only on the equipment itself, but also on how the operator interacts with the system every day. Grinders are one of the most misunderstood parts of espresso systems because their failures are often subtle at first. Unlike machines that leak or stop heating visibly, grinders can degrade slowly while still appearing functional. Burrs wear gradually over time, reducing cutting precision and creating inconsistent particle sizes. Alignment shifts slightly, changing extraction behavior unpredictably. Retention buildup affects dosing consistency. Motor stress develops silently. Calibration drifts over repeated use. And because these problems develop progressively, many people blame the espresso machine itself when the grinder is actually causing unstable extraction underneath. Technicians understand that grinders are not accessories. They are one of the primary control systems behind espresso consistency, and ignoring grinder condition creates endless confusion during troubleshooting. One of the most important things to understand is that most machine failures are processes, not events. Machines slowly drift away from stable operation over time. Pressure fluctuates more than before. Flow becomes slightly uneven. Extraction loses clarity. Heating cycles become less stable. Steam power weakens gradually. Tiny leaks appear. Grinder consistency changes subtly. And because these changes happen incrementally, people often continue using unstable equipment for months before realizing something is wrong. This is why technicians pay attention to patterns instead of waiting for catastrophic breakdowns. Early symptoms matter because they reveal how the system is evolving internally before total failure happens. The technician mindset is fundamentally different from the guessing mindset because technicians do not immediately react emotionally to symptoms. They observe behavior first. They gather information. They isolate variables carefully. They ask what changed, when the symptoms started, how the machine behaves under different conditions, and whether the issue is mechanical, maintenance-related, extraction-related, or workflow-related. That patience is critical because rushing toward repairs without understanding usually creates more problems than solutions. A technician's goal is not simply fixing symptoms quickly. The goal is understanding why the symptom exists in the first place so the correct solution becomes obvious logically rather than emotionally. At this point, you should begin seeing espresso machines differently, not as random complicated appliances, but as systems that behave according to patterns, maintenance, pressure, resistance, heat, extraction, and mechanical condition. And once you understand how machines fail, you become much better at preventing problems, identifying symptoms early, and diagnosing issues calmly before wasting time, money, or unnecessary parts. Because real coffee machine repair doesn't begin with tools. It begins with understanding how the system behaves. One of the biggest differences between beginners and experienced technicians is not knowledge of parts, advanced tools, or even years of experience alone. It's the ability to think clearly while problems are happening. Beginners usually react emotionally the moment something changes. Pressure drops slightly, Espresso starts tasting bitter, steam weakens, water flow slows down, or the grinder sounds different, and immediately they jump toward conclusions without fully understanding the situation. They assume the pump failed, the machine is broken, or some major repair is needed. But experienced technicians approach machines very differently. They understand that symptoms are information. Strange behavior is information. Changes in sound, extraction speed, pressure stability, heat consistency, steam performance, and grinder behavior are all forms of communication from the machine itself. And the technician's job is not to panic. The technician's job is to interpret that information correctly before touching anything. This is where real diagnostics begin. Most beginners believe diagnosis means finding a problem after something already failed. But real diagnosis is much deeper than that. Diagnosis is the process of narrowing possibilities logically until the actual root cause becomes clear. Guesswork asks, what part should I replace? Diagnosis asks, what evidence supports this conclusion? Guesswork reacts to symptoms emotionally. Diagnosis studies relationships between symptoms carefully. For example, low pressure alone does not automatically mean the pump is bad. Pressure behavior must be analyzed alongside flow rate, extraction speed, resistance, machine sounds, maintenance history, and system condition. The same symptom can come from completely different causes depending on context. This is why random repairs often fail. People treat the visible symptom while ignoring the deeper system behavior underneath it. Technicians avoid this by thinking in probabilities instead of assumptions. Every symptom either strengthens or weakens certain possibilities until the problem becomes logically isolated. When experienced technicians approach a machine, they rarely begin by opening it immediately. Instead, they first observe machine behavior under normal operation because behavior often reveals more information than disassembly alone. They watch extraction flow carefully. They listen to pump sounds. They observe heating behavior, steam pressure, recovery speed, water consistency, leaks, vibrations, grinder output, and overall system stability. Because machines often reveal the nature of the problem externally before internal inspection is even necessary. A struggling pump sounds different from restricted flow. Air inside the system behaves differently from pressure loss. Scale restriction creates different patterns than grinder-related extraction instability. Technicians train themselves to notice these distinctions because observation dramatically reduces unnecessary repairs later. One of the most dangerous mistakes beginners make is assuming symptoms always point directly toward the obvious cause. But symptoms often overlap across multiple systems. Weak espresso could come from low brew pressure, but it could also come from coarse grind size, worn burrs, poor puck preparation, stale coffee, restricted heating performance, unstable temperature, or inconsistent dosing. Bitter coffee may suggest over-extraction, but temperature instability and dirty machine buildup can produce similar flavor changes as well. Even strange machine noises can come from completely different causes depending on the timing, pressure behavior, and operating conditions surrounding the sound itself. This is why technicians avoid jumping toward conclusions too quickly. They understand that symptoms are clues, not final answers. Diagnosis requires connecting multiple observations together until a consistent explanation emerges logically. One of the core foundations of professional diagnostics is variable isolation. This means changing one thing at a time while observing the result carefully. Beginners often create diagnostic chaos by changing multiple variables simultaneously. They adjust grind size, replace components, change beans, clean the machine, alter shot timing, and recalibrate settings all at once. Then when the behavior changes, they have no idea which adjustment actually influenced the outcome. Technicians avoid this completely by isolating variables intentionally. If pressure changes, they ask what specifically changed before the symptom appeared. If extraction becomes unstable, they isolate whether the issue originates from grind resistance, flow restriction, temperature behavior, or machine mechanics. This disciplined approach dramatically increases diagnostic accuracy because each adjustment produces usable information instead of confusion. Technicians rarely think in terms of isolated broken parts. Instead, they think in terms of systems under stress. Every component inside an espresso machine influences other components around it. Restricted water pathways increase pump strain. Scale buildup affects heating stability. Grinder inconsistency changes puck resistance. Poor resistance changes pressure behavior. Pressure instability affects extraction balance. This systems-based thinking allows technicians to identify relationships between symptoms that beginners completely miss. Instead of asking, "What part failed?" technicians ask, "What system behavior created this symptom?" That shift in thinking is extremely powerful because it prevents unnecessary repairs and leads to much faster root cause identification overall. Experienced technicians often appear calm during difficult repairs, and many beginners mistake that calmness for confidence alone. But the real reason technicians remain calm is because they trust the diagnostic process itself. They know they do not need to guess immediately. They know symptoms can be narrowed logically over time. They understand that rushing creates mistakes while observation creates clarity. And because they've trained themselves to slow down and interpret machine behavior methodically, even complicated problems become manageable step by step instead of emotionally overwhelming. This mindset is one of the most valuable skills you can develop because technical knowledge without diagnostic discipline often creates more confusion rather than less. Developing a technician mindset means learning to replace emotional reactions with structured observation. Instead of seeing problems as stressful interruptions, you begin seeing them as solvable patterns. You stop fearing machine behavior because you understand that every symptom provides information about what the system is doing internally. You learn to ask better questions. What changed? When did the symptom begin? Does the issue appear consistently or intermittently? Does it happen under heat, pressure, steam use, or extraction load? These questions create direction. And over time, repeated observation builds intuition naturally. Not magical intuition, but experience-based pattern recognition built through structured thinking and careful diagnostics. At this point, you should begin understanding that real diagnostics are not about memorizing random fixes or replacing parts blindly. Diagnostics are about observation, system thinking, variable isolation, and logical reasoning built around machine behavior. Because once you learn how technicians think, machines stop feeling unpredictable. You begin recognizing patterns, narrowing possibilities, and identifying root causes with much greater confidence and clarity. And in the next chapter, we're going to start breaking down the actual systems inside espresso machines: pressure, flow, heat, extraction, and grinder behavior, so you can understand exactly how these machines operate beneath the surface. Before you can diagnose an espresso machine properly, you need to stop seeing it as a mysterious appliance and start seeing it for what it really is: a controlled pressure and heat system designed to move water through coffee under very specific conditions. Because underneath the stainless steel panels, lights, buttons, steam wands, and gauges, every espresso machine is constantly balancing a small number of core variables that determine almost everything you experience in the cup: pressure, flow, temperature, resistance, time. These are the forces shaping extraction every single second, whether you realize it or not. And once you understand how these forces interact together, espresso machines stop feeling random because you finally begin seeing the logic behind their behavior. This is where many beginners struggle. They learn isolated tips without understanding the system underneath them. Grind finer, grind coarser, tamp harder, descale the machine, replace the pump. But without understanding the relationships between the machine's systems, those actions become disconnected reactions instead of intelligent adjustments. Real technicians think differently because they understand that every symptom originates from a change somewhere within the machine's operating balance. Pressure is one of the most misunderstood parts of espresso because many people think pressure alone creates good coffee. But pressure by itself means nothing unless resistance exists to shape and control it. An espresso machine pump is simply generating force to push water through coffee grounds, but the coffee puck itself determines how that pressure behaves during extraction. If resistance is too low because the grind is too coarse, water moves too quickly and extraction becomes weak, sour, thin, or underdeveloped. If resistance becomes too high because the grind is too fine or flow becomes restricted, pressure builds excessively, extraction slows down, bitterness increases, and the machine struggles to maintain stable flow. This relationship between pressure and resistance is fundamental because the machine and grinder are constantly interacting with each other during every shot. Technicians understand this deeply. They know that pressure problems are often not pump problems at all. Sometimes the machine is functioning perfectly while the grinder, puck preparation, or coffee condition is creating unstable resistance underneath. Flow tells technicians more about a machine than almost anything else because flow reveals how the entire system behaves under load. A healthy extraction usually produces smooth, stable flow that develops evenly over time, while unstable flow often exposes deeper system problems immediately. Sudden spurting may indicate channeling or uneven resistance. Extremely slow dripping may reveal excessive restriction, scale buildup, or grinder issues. Pulsing flow patterns can suggest pump instability or air inside the system. Weak flow may point toward restricted pathways, clogged components, poor pressure generation, or insufficient puck resistance. This is why experienced technicians watch extraction carefully instead of focusing only on taste. Flow behavior acts like a visual diagnostic language showing how pressure, resistance, temperature, and machine condition are interacting together in real time. Temperature is one of the hardest variables for beginners to understand because you usually cannot see temperature instability directly the way you can see leaks or pressure fluctuations. But temperature affects extraction constantly behind the scenes. Water that is too cool struggles to extract flavor compounds fully, often producing sourness, sharp acidity, and thin body. Water that becomes excessively hot extracts too aggressively, increasing bitterness, harshness, dryness, and imbalance. Even small temperature fluctuations during extraction can destabilize consistency dramatically. This is why warm-up routines, boiler condition, heating stability, scale buildup, and machine recovery time matter so much. Experienced technicians understand that machines are thermal systems first and mechanical systems second. If temperature stability disappears, extraction quality usually follows. Many beginners treat the grinder like a separate accessory, when in reality the grinder is one of the most important components influencing the entire espresso system. The grinder controls particle size, particle consistency, resistance, extraction speed, flow stability, and flavor clarity all at once. If the grinder produces inconsistent particles, the machine struggles to maintain balanced extraction because water naturally finds weaker pathways through the puck. If burrs become worn, coffee loses uniformity and extraction becomes increasingly unstable over time. Poor grinder calibration changes resistance dramatically. Retention affects dosing consistency. Alignment issues alter extraction behavior unpredictably. This is why technicians never separate grinder diagnostics from machine diagnostics. Because even a perfectly functioning espresso machine cannot compensate for poor grinder performance underneath. Many beginners treat the grinder like a separate accessory, when in reality the grinder is one of the most important components influencing the entire espresso system. The grinder controls particle size, particle consistency, resistance, extraction speed, flow stability, and flavor clarity all at once. If the grinder produces inconsistent particles, the machine struggles to maintain balanced extraction because water naturally finds weaker pathways through the puck. If burrs become worn, coffee loses uniformity and extraction becomes increasingly unstable over time. Poor grinder calibration changes resistance dramatically. Retention affects dosing consistency. Alignment issues alter extraction behavior unpredictably. This is why technicians never separate grinder diagnostics from machine diagnostics. Because even a perfectly functioning espresso machine cannot compensate for poor grinder performance underneath. One of the reasons espresso feels difficult is because small adjustments can produce surprisingly large changes in extraction behavior. Tiny grind adjustments dramatically change resistance. Slight temperature instability alters flavor balance. Minor scale buildup affects flow restriction. Small puck preparation inconsistencies create channeling. A partially worn seal introduces pressure instability. Because espresso operates inside a narrow range of balance, even small system changes can push extraction away from stability quickly. This is why technicians pay attention to details beginners often ignore. Small changes matter because espresso is an extremely sensitive system where pressure, heat, resistance, and flow constantly influence one another during extraction. Technicians rarely focus on isolated symptoms alone because symptoms only make sense when viewed within overall machine behavior. A weak shot means something different depending on pressure stability, flow speed, temperature condition, grinder resistance, and machine history surrounding it. This is why experienced technicians constantly study behavior patterns rather than searching for instant answers. Machines reveal their condition through consistency, extraction rhythm, pressure recovery, heating stability, steam performance, and flow behavior over time. And once you learn how to observe those behaviors properly, diagnosing machines becomes far more logical than emotional. At this point, you should begin understanding that espresso machines are not random collections of parts. They are systems balancing pressure, flow, temperature, resistance, and extraction together continuously. And once you understand how those systems interact, diagnosis becomes dramatically clearer because symptoms stop feeling isolated and start revealing the deeper behavior underneath the machine itself. In the next chapter, we're going to move deeper into real-world symptoms and begin analyzing how common espresso machine problems develop, how technicians interpret them, and how to separate surface symptoms from actual root causes. Every espresso machine tells a story long before it completely fails. The problem is that most people never learn how to read the language. They notice symptoms emotionally instead of diagnostically. The espresso tastes strange, the flow changes unexpectedly, steam becomes weak, pressure feels inconsistent, the grinder sounds different, or the machine suddenly behaves in a way that feels unfamiliar, and immediately the mind jumps toward panic instead of observation. But technicians learn something extremely important early in their careers. Machines almost always communicate through symptoms before major failures happen. Small changes appear first. A slower extraction, a different pump sound, slightly unstable pressure, reduced steam strength, longer heating recovery, minor leaking, uneven flow. These are not random annoyances. They are signals. And the ability to interpret those signals correctly is what separates structured diagnosis from endless guesswork. Because real technicians do not simply repair machines. They interpret machine behavior. Sour espresso is one of the most misunderstood symptoms in coffee because many beginners immediately assume the solution is simply grinding finer. And while under-extraction absolutely can produce sourness, technicians know sour flavors are often part of a much larger system imbalance. Underdeveloped extraction may originate from insufficient resistance, poor temperature stability, uneven puck saturation, weak flow control, grinder inconsistency, or unstable brewing pressure. Sometimes the grinder produces particles too coarse for proper extraction. Other times the machine itself struggles to maintain stable heat during the shot. Inconsistent puck preparation can create channeling where water bypasses large sections of the coffee bed entirely. Even insufficient machine warm-up can destabilize extraction enough to create sourness. This is why technicians never treat flavor alone as a final diagnosis. Taste is information, but taste must be interpreted alongside pressure behavior, extraction timing, flow quality, grinder consistency, and machine condition before the root cause becomes clear. Bitterness creates just as much confusion because people often reduce the problem to one-dimensional advice without understanding the deeper causes underneath. Yes, excessively fine grind settings can absolutely create over-extraction and bitterness. But technicians also understand that excessive temperature, restricted flow, unstable pressure, dirty machine components, stale coffee oils, and prolonged contact time can all contribute to harsh extraction characteristics. Machines suffering from restricted flow sometimes compensate with unstable pressure behavior that overworks sections of the puck unevenly. Dirty group heads alter water distribution. Excessive heat pushes extraction aggressively beyond balance. Grinder inconsistencies create areas inside the puck extracting at completely different rates simultaneously. And because multiple problems can overlap together, bitterness often reflects a broader system imbalance rather than one isolated variable alone. Low pressure is one of the most common symptoms beginners panic about because pressure feels central to espresso performance. The moment shots weaken or extraction speeds up unexpectedly, many people immediately assume the pump has failed. But technicians know true pump failure is only one possibility among many. Restricted flow pathways, air trapped inside the system, scale buildup, leaking seals, poor puck resistance, worn grinder burrs, loose fittings, clogged shower screens, and even improper dosing can all create pressure-related symptoms externally. This is why technicians avoid replacing pumps immediately unless evidence actually supports that conclusion. Instead, they analyze how pressure behaves during operation. Does pressure build slowly? Does it fluctuate? Does flow remain strong while pressure stays weak? Does the issue appear consistently or intermittently? Every one of those details narrows the possibilities further. Slow flow often frustrates beginners because it feels unpredictable. One day extraction looks normal, then suddenly the machine begins choking, dripping slowly, or struggling to maintain proper flow through the puck. But technicians understand that restricted flow usually develops progressively over time rather than appearing randomly. Scale accumulation narrows internal pathways. Coffee residue blocks screens and valves. Grinder adjustments create excessive resistance. Fine particles compact unevenly inside the puck. Solenoid valves become partially obstructed. Old water quality slowly restricts system movement internally. And because restrictions gradually build over repeated use, many people fail to recognize the warning signs early enough. Technicians learn to study how the machine responds under restriction because the nature of the slowdown often reveals where the blockage is developing within the system. Leaks are often treated as minor annoyances until they become catastrophic failures. But technicians understand that leaks are extremely valuable diagnostic clues because they reveal stress points developing somewhere within the machine. A leaking gasket may indicate seal wear, overheating, pressure instability, or improper locking force. Steam leaks often reveal aging valves or internal scaling. Water pooling underneath the machine may point toward hose fatigue, fitting instability, or pressure expansion stress. And small leaks rarely remain small permanently because heat, pressure, vibration, and repeated thermal expansion continuously worsen weak points over time. This is why experienced technicians take leaks seriously even when machine performance still appears mostly normal. The leak itself may not be the largest problem. The leak may simply be exposing a larger system issue developing internally. The more machines technicians work on, the more they begin recognizing repeating behavior patterns across completely different repair situations. Certain extraction behaviors consistently point toward grinder instability. Certain pressure fluctuations repeatedly indicate restriction or air intrusion. Certain steam weaknesses reveal scaling patterns. Certain leak locations expose common failure points. Over time, diagnosis becomes less about memorizing isolated fixes and more about pattern recognition built through observation. But pattern recognition only develops when you slow down enough to study machine behavior carefully instead of reacting impulsively every time a symptom appears. This is why technicians constantly emphasize observation. Machines reveal themselves through repetition. One of the hardest habits for beginners to develop is patience. Most people want immediate answers the moment a symptom appears. They want certainty instantly. But experienced technicians understand that rushing toward repairs too early often destroys valuable diagnostic information. Machines need to be observed under real operating conditions first. Symptoms need context. Patterns need confirmation. Because once parts begin getting replaced randomly, the original system behavior becomes harder to interpret accurately. Technicians know that slowing down early often speeds up the entire repair process later because careful diagnosis prevents unnecessary confusion and wasted effort afterward. At this stage, you should begin realizing that symptoms are not random frustrations. They are structured clues revealing how the machine behaves internally under pressure, heat, flow, resistance, and extraction stress. And the better you become at reading those clues, the less intimidating espresso machines become overall. Because diagnosis is not magic. It is observation, pattern recognition, systems thinking, and logical interpretation built over time. In the next chapter, we're going to move deeper into grinder diagnostics and understand why grinders silently control far more of espresso behavior than most people realize. One of the biggest mistakes people make when learning espresso is believing the espresso machine is the center of everything while the grinder plays only a supporting role. In reality, experienced technicians and professional baristas understand something completely different. The grinder silently controls a massive percentage of extraction behavior before water even touches the coffee. You can own an expensive machine with stable temperature, strong pressure, and perfect steam performance. But if the grinder produces inconsistent particles, unstable resistance, poor distribution, or worn burr performance, the entire espresso system begins collapsing underneath. And this is exactly why so many people endlessly chase machine upgrades without realizing the grinder is often the real source of instability the entire time. Grinders shape resistance. Resistance shapes pressure behavior. Pressure shapes extraction flow. Extraction flow shapes flavor balance. Everything begins at the grinder. This is why technicians never separate grinder diagnostics from machine diagnostics. Because espresso is not created by one machine alone. It is created by the interaction between grinding, pressure, flow, heat, and puck resistance working together as one connected system. Many beginners become obsessed with grind size alone because most coffee advice online reduces grinder adjustments to simple phrases like grind finer or grind coarser. But technicians know the real issue is usually consistency, not just fineness. Because espresso extraction depends on creating an evenly resistant coffee bed where water moves predictably through the puck under pressure. If the grinder produces wildly different particle sizes at the same time, extraction becomes chaotic. Fine particles over-extract while larger particles under-extract simultaneously. Water begins searching for weaker pathways through the puck. Channeling develops. Flow destabilizes. Flavor becomes muddy, sour, bitter, hollow, or inconsistent shot to shot. This is why grinders with worn burrs or alignment issues often create espresso that feels impossible to dial, and no matter how much people adjust the machine itself. The problem is not always the espresso machine. The problem is that the coffee entering the machine is already inconsistent before extraction even begins. Burr wear is one of the most overlooked causes of espresso inconsistency because it develops gradually over long periods of time rather than appearing suddenly. When burrs are sharp and aligned correctly, they cut coffee particles more evenly and predictably. But over repeated grinding cycles, burr edges slowly lose precision. The grinder begins crushing more than cutting. Particle uniformity weakens. Fine dust increases. Extraction balance becomes unstable. Shot timing starts fluctuating unexpectedly. Dialing in becomes frustrating because small adjustments no longer behave predictably. And since this degradation happens progressively, many people adapt slowly to declining grinder performance without realizing how much consistency has disappeared over time. Technicians understand that grinders rarely fail dramatically at first. Most grinder problems begin as subtle instability that slowly expands into larger extraction inconsistency later. Even high-quality grinders can struggle if burr alignment becomes unstable because alignment directly influences how evenly coffee particles are produced. Misaligned burrs create uneven grinding surfaces where parts of the burr touch differently during operation. This creates inconsistent particle sizes throughout the grind distribution, which then creates uneven resistance inside the puck during extraction. Water naturally exploits those inconsistencies under pressure, leading to channeling, unstable flow, unpredictable shot timing and fluctuating flavor clarity. What makes alignment problems difficult is that many grinders still appear functional externally while producing unstable extraction internally. This is why technicians often inspect grinders carefully even when the espresso machine itself appears mechanically healthy. Because sometimes the machine is innocent while the grinder quietly destabilizes everything underneath. Retention is another hidden grinder issue many beginners underestimate because it is not immediately visible during extraction. Retention refers to coffee grounds remaining trapped inside the grinder between uses. Over time, retained coffee becomes stale, oily, compacted, and inconsistent. Fresh coffee entering the grinder mixes with older retained grounds, creating unstable extraction behavior shot after shot. This can lead to confusing flavor inconsistency even when grind settings appear unchanged. Technicians understand that stable espresso requires repeatable conditions, and retention quietly disrupts repeatability underneath the surface. This is why grinder cleaning, purge routines, and internal maintenance matter far more than most people realize. Technicians rarely diagnose grinders by taste alone because flavor symptoms can overlap across multiple systems. Instead, they study grinder behavior directly. They evaluate particle consistency, burr condition, alignment stability, motor performance, retention levels, grind adjustment responsiveness, and extraction repeatability. They observe whether adjustments create predictable changes or unstable reactions. They monitor whether shot timing behaves consistently across repeated extractions. Because grinders reveal their condition through patterns, just like espresso machines do. A healthy grinder produces repeatable resistance. An unstable grinder produces confusion. One of the biggest reasons people misdiagnose espresso machines is because grinders influence so many extraction variables indirectly. A machine experiencing unstable shots may appear to have pressure issues when the grinder is actually producing inconsistent resistance. A shot running too quickly may look like weak pressure while the grinder is simply too coarse. Bitter extraction may appear temperature-related while the grinder creates excessive fines inside the puck. Because grinders affect extraction invisibly before brewing even begins, many people blame the espresso machine for symptoms originating from the grinder underneath. This is why experienced technicians always analyze both systems together instead of isolating one from the other. Technicians understand that grinders are not simple accessories attached to espresso machines. They are precision resistance control systems directly shaping how water interacts with coffee under pressure. And because grinders influence extraction at such a fundamental level, professionals treat grinder consistency, cleanliness, calibration, alignment, and burr condition with enormous importance. A stable grinder creates predictable extraction. Predictable extraction creates repeatable diagnosis. And repeatable diagnosis allows technicians to isolate real machine problems far more accurately, without confusion from unstable grinding variables underneath. At this point, you should begin realizing that espresso quality and machine diagnosis cannot be separated from grinder behavior. The grinder controls resistance, consistency, flow stability, and extraction balance long before brewing even begins. And once you understand how grinders influence the entire espresso system underneath, diagnosing machine behavior becomes dramatically clearer because you stop blaming symptoms blindly and start identifying where instability actually originates. In the next chapter, we're going to move deeper into real-world repair logic and begin understanding how technicians systematically isolate faults, narrow possibilities, and troubleshoot machines step by step without random guessing. One of the biggest myths about coffee machine repair is the idea that experienced technicians instantly know what is wrong the moment they look at a machine. Beginners often imagine technicians have some kind of special intuition that immediately identifies every failure perfectly. But the truth is far more practical than that. Real technicians are not magically guessing correctly. They are following structured diagnostic logic step by step while eliminating possibilities carefully. And this is extremely important to understand because professional troubleshooting is not about memorizing thousands of random fixes. It's about building a repeatable process that works even when the problem is unfamiliar. Every machine becomes easier to diagnose once you stop chasing isolated symptoms emotionally and start narrowing possibilities systematically. That process is what separates organized technicians from frustrated guessers. Because guessing creates chaos, systems create clarity. One of the most common beginner mistakes is starting the repair process by assuming which part failed before properly understanding the symptom itself. The moment pressure changes, they assume the pump failed. If the machine leaks, they immediately think a gasket must be replaced. If extraction becomes inconsistent, they blame the grinder instantly. But technicians work in the opposite direction. They begin with behavior first. What exactly is the machine doing? When does the symptom appear? Is it consistent or intermittent? Does the problem happen under heat, pressure, steam use, or extraction load? Does the machine behave differently after warming up? These questions matter because symptoms contain context, and context dramatically changes the direction of diagnosis. A weak pump behaves differently from restricted flow. Scale buildup behaves differently from grinder instability. Air inside the system creates different patterns than pressure leakage. Technicians study those differences carefully before deciding where to investigate deeper. Beginners often rush toward complicated explanations because complex problems feel more dramatic and emotionally convincing. But experienced technicians know something very important. Simple failures happen constantly. Dirty shower screens, restricted flow paths, scale buildup, loose fittings, poor grinder calibration, air trapped inside the system, worn seals, blocked steam tips, incorrect dosing, inconsistent puck preparation. These small issues create enormous performance problems surprisingly often. This is why technicians typically start with the simplest and highest probability possibilities first before moving toward more complicated repairs. Because opening the machine immediately without ruling out simple causes first wastes time, creates unnecessary confusion, and sometimes introduces entirely new problems during disassembly. Professional troubleshooting is not about proving how advanced your knowledge is. It's about identifying the real problem efficiently. One of the most powerful skills technicians develop is the ability to eliminate possibilities systematically instead of trying to guess the exact answer immediately. This changes the entire mindset around troubleshooting because diagnosis becomes less about certainty and more about narrowing probabilities logically. If pressure remains stable, certain failures become less likely. If temperature behaves normally, heating problems move lower on the list. If extraction changes only under specific grind settings, resistance becomes more important than pump behavior. Every observation either strengthens or weakens certain explanations. Over time, the possible causes become smaller and smaller until the most likely root cause remains. This process is extremely important because many symptoms overlap across different systems. Technicians avoid confusion by continuously reducing uncertainty step by step, rather than emotionally jumping toward conclusions too early. Professional troubleshooting becomes dramatically easier once you learn how to isolate systems instead of viewing the machine as one giant problem. Technicians mentally separate machines into functional sections: pressure generation, heating systems, flow pathways, extraction resistance, steam systems, grinders, electrical behavior, and maintenance condition. Then they test how each section behaves independently under load. This prevents symptoms from blending together into confusion. If flow weakens but pressure remains stable, technicians begin focusing differently than they would if both pressure and flow collapse together. If steam performance weakens while brew extraction remains stable, the problem moves towards specific thermal or steam-related systems rather than full machine failure. Isolating systems creates structure, and structure dramatically improves diagnostic accuracy. Random part replacement is one of the fastest ways to create confusion during repairs because once multiple variables change simultaneously, the original diagnostic picture becomes distorted. Many beginners replace pumps, valves, seals, grinders, thermostats, or electrical components without strong evidence simply because those parts are commonly associated with certain symptoms online. But technicians understand that replacing parts without confirming the root cause can create false confidence temporarily while the real problem continues underneath. Even worse, unnecessary repairs sometimes introduce new problems accidentally through improper installation, damaged fittings, alignment issues, or disturbed components that were functioning normally before. This is why professionals value diagnosis more than repair itself. Correct diagnosis reduces unnecessary intervention dramatically. Technician intuition is often misunderstood because people imagine intuition means magically knowing answers without thinking. But real intuition is simply pattern recognition built through repeated structured observation over time. Experienced technicians have seen pressure instability hundreds of times. They've heard restricted pumps repeatedly. They've watched grinders drift out of calibration. They've observed scale buildup patterns across many different machines. Over time, the brain begins connecting symptoms faster because familiar behaviors repeat consistently. But that intuition only develops correctly when the diagnostic process itself is structured. Random guessing does not build reliable intuition. Careful observation does. The most important rule in troubleshooting is simple: never let urgency destroy clarity. The moment frustration takes over, people stop observing carefully. They rush adjustments. They skip testing steps. They replace random parts. They change multiple variables at once. And suddenly the machine becomes even more confusing than before. Technicians learn to slow down intentionally because calm observation almost always produces better repairs than emotional reaction. Machines rarely hide the truth completely. They reveal it gradually through patterns, symptoms, behavior changes, and system responses. The technician's job is to remain patient enough to interpret those clues correctly. The most important rule in troubleshooting is simple: never let urgency destroy clarity. The moment frustration takes over, people stop observing carefully. They rush adjustments. They skip testing steps. They replace random parts. They change multiple variables at once. And suddenly the machine becomes even more confusing than before. Technicians learn to slow down intentionally because calm observation almost always produces better repairs than emotional reaction. Machines rarely hide the truth completely. They reveal it gradually through patterns, symptoms, behavior changes, and system responses. The technician's job is to remain patient enough to interpret those clues correctly. One of the biggest misconceptions people have about espresso machine repair is believing that most failures happen suddenly and without warning. In reality, a huge percentage of coffee machine problems develop slowly over time through neglect, contamination, mineral buildup, unstable habits, poor cleaning routines, and repeated stress accumulating inside the machine day after day. Technicians see this constantly. Machines rarely wake up one morning and decide to fail randomly. Most failures are the final stage of smaller problems that were ignored for weeks, months, or even years beforehand. Scale slowly narrows internal pathways. Old coffee oils harden inside group heads and valves. Steam systems accumulate milk residue. Seals dry out under repeated heat cycles. Burrs were gradually. Water quality slowly damages internal components. And because these changes happen progressively, many people adapt to declining performance without realizing how unstable the machine has actually become underneath. This is why professional technicians treat maintenance as part of diagnosis itself, because maintaining stability is often easier, cheaper, and safer than repairing full breakdowns later. One of the most dangerous things about poor maintenance is that dirty machines often imitate much larger mechanical failures. A clogged shower screen may appear like pressure instability. Heavy scale buildup can mimic weak pump performance. Dirty solenoid valves create inconsistent flow behavior. Old coffee oils distort extraction taste so badly that people blame grinders, beans, or brew pressure incorrectly. Steam wand residue weakens steam performance gradually until users assume major heating problems exist internally. Technicians understand this extremely well, which is why experienced professionals almost always inspect machine cleanliness before assuming expensive component failure. because sometimes the machine itself is still healthy underneath layers of restriction, contamination, and neglect. Scale is one of the most destructive long-term enemies inside espresso machines because mineral deposits slowly interfere with nearly every major system simultaneously. As water heats repeatedly, dissolved minerals begin attaching themselves to internal surfaces, narrowing pathways, reducing heat transfer efficiency, restricting valves, weakening flow stability, stressing pumps, and destabilizing temperature consistency over time. The dangerous part is that scale often develops invisibly deep inside the machine long before symptoms become obvious externally. Machines may still appear operational, while internal stress quietly increases month after month underneath. Technicians know that heavily scaled systems often produce confusing, overlapping symptoms because scale affects pressure, temperature, and flow all at the same time. This is why water quality and descaling routines are not optional details. They directly influence machine lifespan and diagnostic stability. Coffee may seem harmless because it smells pleasant and feels natural, but coffee oils become surprisingly destructive when allowed to accumulate repeatedly inside espresso systems. Over time, oils oxidize, harden, and coat internal surfaces, group heads, baskets, shower screens, valves, and flow pathways. This buildup changes water distribution, alters extraction balance, creates bitterness, restricts flow, and destabilizes consistency shot after shot. Many people mistakenly believe flavor problems originate from beans or grinders when stale residue inside the machine is actually contaminating every extraction underneath. Technicians understand that espresso flavor depends not only on fresh coffee entering the machine, but also on the cleanliness of every surface water touches during brewing. Technicians know that maintenance is not about occasional deep cleaning alone. Stability comes from small daily habits repeated consistently over time. Wiping steam wands immediately after use prevents hardened milk contamination. Purging group heads reduces residue accumulation. Cleaning baskets maintains stable flow distribution. Emptying grinder retention improves freshness and consistency. Monitoring water quality prevents long-term scale stress. These habits may seem minor individually, but together they dramatically reduce machine instability over months and years of use. Machines that receive consistent small maintenance often outperform neglected machines with expensive upgrades because reliability depends more on stability than complexity. Technicians know that maintenance is not about occasional deep cleaning alone. Stability comes from small daily habits repeated consistently over time. Wiping steam wands immediately after use prevents hardened milk contamination. Purging group heads reduces residue accumulation. Cleaning baskets maintains stable flow distribution. Emptying grinder retention improves freshness and consistency. Monitoring water quality prevents long-term scale stress. These habits may seem minor individually, but together they dramatically reduce machine instability over months and years of use. Machines that receive consistent small maintenance often outperform neglected machines with expensive upgrades because reliability depends more on stability than complexity. Professional technicians do not see maintenance as separate from repair. They see maintenance as proactive diagnosis happening before visible failures fully develop. Cleaning reveals leaks earlier. Descaling prevents restriction buildup. Grinder maintenance preserves extraction stability. Daily observation catches unusual behavior before systems become heavily damaged. In many ways, maintenance is simply long-term machine awareness practiced consistently over time. And once you begin thinking this way, espresso machines stop feeling unpredictable because you are no longer reacting only after major failures happen. You are actively preserving stability before instability spreads. At this point, you should begin understanding that many espresso machine problems are not sudden disasters appearing randomly overnight. They are long-term stability problems built slowly through neglect, contamination, mineral buildup, and ignored warning signs over time. And once you develop strong maintenance habits, diagnosing machines becomes dramatically easier because the system itself remains cleaner, more stable, and more predictable underneath. In the next chapter, we're going to move deeper into advanced diagnostic thinking and explore how experienced technicians approach difficult problems, overlapping symptoms, and complex machine behavior when simple answers no longer exist. Now that you understand the deeper technician mindset behind espresso machine diagnosis, maintenance, grinder behavior, and troubleshooting systems, it's time to apply that thinking to realistic situations technicians encounter constantly in the real world. Because theory only becomes powerful once you learn how to recognize patterns during actual machine behavior. And one of the fastest ways to strengthen diagnostic confidence is by studying practical symptom scenarios and understanding how experienced technicians mentally approach them step by step. This section is not about memorizing perfect answers mechanically. It's about learning how technicians think through uncertainty logically while narrowing possibilities calmly and efficiently. Every scenario you're about to see represents the same core principle repeated again and again: symptom, system, observation, elimination, confirmation. Imagine a machine producing espresso that tastes sharp, sour, weak, and thin while the shot also runs unusually fast. Many beginners panic immediately and start blaming temperature, pressure, beans, or even the entire espresso machine itself. But technicians slow down and analyze the symptom pattern logically. Sour flavor combined with fast extraction often points toward under-extraction behavior. Now the technician begins narrowing possibilities. Is the grind too coarse? Is the dose too low? Is puck preparation inconsistent? Is water bypassing through channeling? Is grinder consistency unstable? Notice what's happening here. The technician is not emotionally chasing. Now imagine the opposite situation. The shot drips slowly. Extraction takes too long, crema appears dark and heavy, and the espresso tastes bitter, dry, and harsh. Again, beginners often overcomplicate the diagnosis emotionally. But technicians begin with extraction logic first. Slow flow combined with bitterness often suggests excessive resistance and over-extraction behavior. The grind may be too fine. The puck may be overdosed. Flow pathways may be partially restricted. Scale buildup could also contribute if flow instability exists throughout the machine itself. Technicians begin testing the highest probability causes systematically rather than assuming catastrophic machine failure immediately. A machine showing weak extraction pressure often causes immediate panic because many people instantly assume the pump itself has failed. But experienced technicians observe deeper behavior first. If the pump sound remains normal and stable, technicians begin considering alternative explanations before replacing anything. Restricted flow pathways, scale buildup, leaking seals, bypassing water, loose fittings, or puck resistance issues may all create weak pressure symptoms without the pump itself being defective. This is why professionals never diagnose based on one symptom alone. They study the full behavior patterns surrounding the symptom before making conclusions. Intermittent inconsistency frustrates people more than obvious failure because the machine occasionally behaves correctly, creating confusion and uncertainty. One shot tastes perfect. The next becomes sour or weak unexpectedly. In these situations, technicians begin thinking about instability variables rather than permanent failures. Grinder inconsistency, retention buildup, temperature fluctuation, puck preparation variability, intermittent flow restriction, or unstable pressure recovery may all contribute. The key insight here is that inconsistent behavior often points toward unstable conditions rather than complete component failure. Technicians search for variables changing between shots instead of assuming the machine itself is completely broken. A machine producing good steam initially but weakening gradually during operation tells technicians something extremely important. The issue may involve thermal recovery rather than immediate steam generation failure itself. Scale buildup, heating inefficiency, boiler stress, temperature regulation instability, or restricted steam pathways may all reduce long-term steam consistency. Technicians observe how the machine behaves over time instead of focusing only on the first symptom moment, because the timing of failure often reveals the nature of the problem underneath. One of the most important lessons technicians eventually learn is that sometimes the espresso machine itself is functioning correctly while the surrounding workflow creates the instability instead. Poor grinder calibration, old coffee beans, inconsistent puck preparation, bad distribution, incorrect dosing, dirty baskets, poor water quality. These external variables dramatically influence extraction behavior even when the machine itself remains mechanically healthy underneath. This is why experienced technicians analyze the entire coffee system instead of isolating blame onto the machine automatically. Because espresso quality is created by interaction, not by one component alone. The goal of these scenarios is not memorizing fixed answers mechanically, because real machines will always present unique combinations of behavior over time. The real goal is learning how technicians approach uncertainty itself. Observation before assumption, systems before emotion, elimination before replacement, structure before guessing. Because once you develop that mindset deeply, machines stop feeling unpredictable and intimidating. They become understandable systems revealing clues through behavior patterns step by step. And that is the foundation of real technician confidence.